So this video is going to go over control flow, the main function, function calls, arguments, parameters, and local and global variables. So put your hats on. The way it goes is we're going to run the program. It's going to go to line number 1, but the interpreter, which is the program that runs the program, has a rule that says it does not run function definitions. Right. So it's going to come here to line number 1 and say, hey, that's a function definition. So I'm going to ignore you down to line 4. And then it's going to go to line 5, nothing's there. It's going to go to line 6. It's going to ignore line 6 to 9 for the same reason. It's going to get to line 10, nothing's there. It's going to go to line 11, down to 16, ignore that for the same reason. Get to line 17, nothing there. Line 18, there's main. And here is a function call, not a function definition. So it's going to go and look for the function definition for main. Right? This is saying jump to line 11 and run the function definition for main. Okay, cool. So we're here in function definition for main. It's going to run line 12, which says put the value that this expression evaluates to into the variable on the left side of the equal sign num. So this expression is a little bit complicated because it's trying to int or typecast the value as an integer, but it's not a value. It's a function call. Right. So this is a built-in function called input, and it's a function call. It's going to run that code. It's going to make the box pop out. I'm going to type in the number 5. I'm going to hit enter, and this expression here is going to be replaced with the value 5, the number that I typed in. And input, if you don't recall, takes in input from the keyboard as a string. So this is not the number 5. This is the letter 5 or the word 5. So it's that, and so that's why we need to int it or typecast it as an int, so it turns into the number 5 like that. So num now contains the number 5. Okay, so all of you guys should know all of that. And then we get down to line 13, and it does the same thing, right? It needs to evaluate the expression on the right side of the equal sign, and it goes ahead and it says, hey, this is a function call, so it's going to go and look for the function definition. Finds it right here on line number 1, but we have something special with this function call. It has the variable num inside of the parentheses, and so what this is called is a argument. So I'm going to type it right here, argument, and what it is that we're giving the function squareIt a value to work with. Right. So what is it squareIt going to do? It's going to square the number that we give it. We give it a 5, it's going to give us back 25. We give it 10, it's going to give us back 100. And so we're going to run squareIt with the value of num, which is 5, and it's going to jump up to line number 1, and right here, this n right there is a parameter. Right, and so parameter and arguments are kind of the same thing. They're two ends of the same thing. They're same in the same way that this would be the quarterback and this would be the wide receiver. So we're throwing the value 5 over here to the function definition of squareIt, and squareIt is catching it in the parameter, which is a local variable, temporary variable that you use just for this function definition, n, right? So now n is equal to what num was equal to, and num is equal to what the input was equal to, and input was 5 from the keyboard, right? The person typed in 5. So we're up here on line number 1, n is equal to 5. It comes to line 2. It does 5 times 5, square is equal to 25, and then we got the return keyword, which is going to return the value that's in square, which is 25. So what does return do? It returns to where the function was originally called. So it jumps back to line 13, and now this expression has been evaluated because the return value is going to be right there. Right? So then square is going to equal to 25. Okay, great. So square is equal to 25, and then we get to line 14. It does the same thing, except it cubes it. So it jumps up here, and n is equal to 5. It does 5 times 5 times 5, so cube is equal to 125. It returns the value of cube, which is 125. It jumps back down to here, and it prints out 125. Right? And so, sorry, not prints out, but returns the value 125. So cube is now equal to 125. And then we print everything in one print statement by typecasting the integers as strings and concatenating all the strings together. Okay. So after it prints that out to the screen, that is the end of the function definition for main. So what does it do? It goes back to where main was originally called, which is down here on line 18. And then it goes down to line 19, and then it ends our program because there's nothing left to execute. There's no more instructions, right? And so that is the control flow of the program. That's what arguments are, and you can't have more than one argument. You can put a 5 and a 10, right? But if you do have more than one argument in your function called, you need to define more than one parameter up in the function definition. All right, so that's that. Now we're getting to local and global variables, right? So if we look here, all of these, the reason why we need to, you might be thinking to yourself, like, why are we passing values of variables to function definitions? What's the point of that, right? Because what we've been doing thus far is we've been, let's say we can call other num is equal to 56, right? All right, so this variable other num here is a global variable. And why? Because he is created right here on line number 1, and he's created outside of a function definition, right? So this guy is global. And what does global mean? It means he can be seen everywhere. He can be used out here. He can be used inside of a function definition. He can be seen everywhere. So that's what we've been doing so far. We've just been creating global variables, and we've been working with global variables, right? Well, that brings into the spotlight a local variable. And so what is a local variable? It's a function a variable that's been created inside of a function definition, like num and square and cube. These guys are all local. And what does local mean? That means that they exist in main, and they've been created in main, and they only exist in main. They can't be used anywhere else. Like if I came up here and I said print num, it would break. It would say there is no num, and that's right, because there is no num in this function definition qubit. The way that I like to imagine it is these guys are all different islands, right? And this is back in the day where travel from island to island wasn't as simple as we have today. So anything that was created here in main stays on island main. Anything that's created here in island qubit stays on island qubit, right? The only way you can pass a variable from one island to another island is by sending it on an airplane in a function call. Right, so you pack it up as an argument, you fly it off over to the second island. The second island has to receive it in his airport, and now he can use that value to do whatever he wants to do with it, right? Whether it's square it or cube it. And so you might now be asking yourself again, like, so who cares? Why don't I just make everything global? Why don't I make cube global? Why don't I make num global, square global, cube, all these variables global, and just use them in my function definitions, right? So that would make life easier, and I could see why you say that, because as of right now, your programs have been so small, it doesn't really matter, right? But best programming practice is that you keep everything as localized as possible. And now you might be asking yourself, why? Who cares, right? Well, imagine that you are the software developer, right? The senior software developer. You've been given a large project. The classroom is your software development team. You split that project up into 26 different parts, and you give one part to each person in the class, and you tell them, complete that. They go ahead and complete that with your mindset, and they make all their variables global. So they make a variable called X, they make a variable called Y, they make a variable called num, and they write their program. It works perfectly. They're part of it, right? Their 1/25th of the program works. And so great, now everyone's done. They all give the senior software developer, back their different parts of the program. You compile it all together, and you hit the run button, and nothing works, right? And why does nothing work? Because programmer A used the variable X, the name variable X, as a global variable. Programmer C used the variable X as a global variable in their program. So when you put them together and you run it, the value for X is not what it should be in the various parts of your program. That is bad, right? So if you keep everything as local as possible, then you won't run into that problem, right? So if I have programmer A define a local variable X, and I have programmer C define a local variable X, and then I go ahead and compile their programs together and put them together into one larger program, I don't have any issues, because those variables are local, and they don't care that there are two variables called X, because they're local and they're different, like, I don't know, like locations to store a value. So that's like a simplified explanation for why we want to keep everything as local as possible. And the reason why function definitions take in arguments, and why we have parameters, and why we have all of this, what you thought was nonsense. There's a purpose and a point, but at the point that you're at now in the curriculum of computer science, it doesn't really make sense to you, but hopefully it shined a little bit of light on the matter.